Welcome everybody to August 3rd Ortelius architecture meeting. Let me share my screen. Get a bunch of stuff out of the way. So I don't know for those of you that caught this, but Tracy put together a presentation. We had a quick chat. We had like a 20-minute chat with Jim Zimlin. Jim is the executive director of all of the Linux Foundation. And he reached out to us because he got wind that Ortelius is going to be having the data do AI stuff. And what we did was we put together a quick presentation I'm going to run through. And then we'll get on to kind of like our to-do list. Just our basic mission statement, you know, like I like to say we're the garbage collectors of the software world. We go out and pick up a bunch of stuff and store it. And that goes across the supply chain as well as you know, deployments and stuff like that. Our typical statement about what we're collecting, what we're going to do with it, with the trying to get away from siloed data. And one of the things that exists today that doesn't exist in when people talk about AI and threat modeling is there's no data. So you can't do anything with AI with no data. So that's where Ortelius comes into play. And the top boxes here are what we're currently kind of able to do and gather. Some of the things that we need to be able to address is to take basically the goal would be to start with every single open source project like under the Linux Foundation, start collecting their supply chain data and be able to do some other stuff with that data. But the first step will be collecting the data. And then obviously it'll be this has always kind of been in play with Ortelius. We would beef up our public SaaS version, so we'd actually convert our Azure cluster from a dev world into a production world. That's going to take some work because we'll have to figure out how to fund it. Because we're going to be storing, I envision probably 2 terabytes of data is what we're looking at on that front. And then on the private side, somebody like USA, which is a insurance company here in the States, they could be running their own private version of Ortelius. And I've always envisioned that we'll do some sort of federation between the two. We haven't really gotten into the architecture down the road on how to aggregate federated data, but I think the Emporis folks may be able to help us with that. But that's the angle that we're looking at. Some of the stuff that was,
sorry to interrupt you.
No, go ahead.
Is this presentation freely available for us to use around the world? Okay.
Yep. There's a couple things that we need to tweak on it. Okay. So it's I'll show you at the end. And Sasha, cool. We had to bring in your cow.
I can't wait to come to your side of the States. I've never been to America. I've got to come there, man. I need to meet a few UFOs.
So basically where Ortelius stands today, we kind of view it as an MVP. We're proving out what we got. But for the AI side, we know we can get the data and we need to be able to get large amounts of data, be able to do the modeling. So let me see if this is, yep. So the first AI model that we were thinking of is basically trying to answer the question, are the project pipelines compliant with security? And if they're not, how do we fix that? So for example, we're able to capture that the pipelines that are running don't generate an SBOM. And we know that that pipeline is a GitHub action. the AI model, just like with GTP, should be able to generate. We should be able to generate updates to that GitHub action, for example, and add in the SBOM collection, generation and collection. Other things like linting, being able to add linting into your pipelines and being able to do this automatically, so developers don't have to do it. Think of it as the Penabot for security things missing in a pipeline. So, and this is where we would, you model the top performing pipelines, and then you model the ones that you currently have, and then you figure out the difference between the two of them. So that's like the first AI proposition. The second one is, how do we know if we've been impacted by a CVE? So this is more along the creating an emergency alert system. How do we get notify people on the producers and the consumer side about a critical vulnerability that needs to be addressed right now? A lot of the vulnerabilities out there, when you look at them, there may be a critical vulnerability, but the case for you to exploit that vulnerability is very low. You got to work your way through a firewall, then you got to have root access to the operating system. A bunch of stars have to align for you to exploit it in that case. But what we want to be able to do is do an emergency response system that would not only say that there's a CVE out there, but also go in and figure out how to fix it. How do you make coding changes, or is it just a dependency package bump, for example? So that's the next one that we would be doing, that generating the threat models and fixing it basically. This one is this one I've run into, and it has to deal with your dependencies, more dependency management. On the Persia project, we ran into this. I found it by doing a bunch of package verification, and they were actually using two different JSON parsers. One was secure, one was unsecure. So in this case, it's like, all right, we need to decide, this project is consuming multiple dependencies. They're doing the same thing. How do we get them to use the right version? This one is more notification and decision making versus being able to go in and make coding changes. There may be some pieces on the AI model that we can do on the pruning a dependency tree. I always use the hello world for Node.js. It brings in a couple thousand packages just to print hello to the console. That shouldn't be required. We should be able to have a small dependency tree. And we have a small dependency tree, we have a small attack plane. I think that was the last one. Oh, and this one is going to be, this is where Sasha, I was saying further on, we're still working on this slide deck. This is going to be Emporus, how we can leverage Emporus for threat modeling.
I've got a great use case already that I can use here in South Africa with IBM. They have these weird little executable Java-y things that need to be installed on AIX machines, right? And so Ortelius and Emporus are perfect for this, because they could have all of their dependencies for all their little IBM thingies, well, not little, these massive data power things and MQ messaging, so all that stuff. They could store all their dependencies and use Ortelius to have a nice view into all of that, right?
Yep.
So my one colleague is already installing Emporus now in AWS to do this.
Cool.
So we can stick Ortelius in there. Is there at the moment a connection between the two, or is it still being fleshed out?
That's still being fleshed out. On the last Emporus meeting last week, we happen to have like Kat was there, Andy was there, Alex. So the main players were all there. So they are getting excited to get things moving again. So on that front, I have not looked, but Alex was going to add issues into the Ortelius repo, and I think he was going to label them as Emporus issues. So if we go into the repo.
And I'm assuming Persia fits into this perfectly too, right? With Ortelius kind of as a front end for that.
Yeah, so the Persia is the distributed build network. And one of the things it would do would be to build, the same object in multiple locations. And then once it says, yes, we all built the same thing, then it has to take that artifact and add it to somewhere. And that somewhere I'm envisioning is going to be an OCI registry like Emporus.
Does Persia negate needing a Nexus server, something to store your dependencies for your programmers, your developers?
Well, the way
isn't it peer-to-peer? It's decentralized, right?
Yeah, and that's one of the things that that the Persia project started out was they were writing the peer-to-peer network from scratch. And I think that project's kind of stalled a little bit, but I think what we can do is you can take the OCI register and they have these storage drivers, and the storage driver, you can go in and replace the storage driver. So the storage driver is just like an interface that you could come into. So if you want to store everything in an S3 bucket, you can have a storage driver for S3 versus a storage driver for Google Cloud Storage. So under the covers in the OCI registry, you can have a storage driver for IPFS. And when you do that, you end up having a distributed OCI registry over IPFS.
Because okay, I was understanding Persia as like I could have a node running on my. Do I connect to a central node? Like I could have the dependencies locally on my machine because Persia synced them onto my machine using myself as like a.
Yep.
It's like a torrent.
Yeah, exactly. And that's what it is. And
basically what it is, I'm a torrenting machine. Yeah. And I just keep a copy, right? And then my buddy can have his locally on his machine, and they can use dependencies locally, something to pull them across the internet.
Yeah. So that's where I'm using the OCI with the IPFS driver. The IPSF driver is the peer-to-peer networking that like NFT storage uses. And the BitTorrents and stuff like that all use basically the IPFS storage. So you could run a node yourself, connecting the OCI registry with the IPFS to other peers, and then you would be able to bring in those pieces. So it gives you that peer-to-peer networking with the OCI registry.
So could my developers then, I could have like an internal kind of peer-to-peer type of network.
Yep.
Without using Nexus, I wouldn't need a Nexus server at all. I could just use that technology for my developers to have their dependencies pulling from. And I could control the dependencies from that point of view, what versions, through Ortelius and that type of thing.
It would be things like Nexus and JFrog's Artifactory would still be better to use because they have that gateway process where you can say, I want these things to come into the artifact repository, and I want to keep these things out. The OCI registries don't have that filter in place yet.
But they will get it. Do you think they'll go that way?
I think what will happen is OCI registries anything can be put into them, but there'll be enough data in there to make rules to say, I don't want this to come out. I think that's the way it's going to be architected.
You know, I'm asking because I went to look at JFrog Artifactory and it's so expensive. It's really
Yeah,
expensive. Well, for rands, right? For people with rands, it's just too much.
yeah. So
So I'm
that
trying to find a poor man's version.
yeah, and the other thing that even though the OCI registry spec allows any type of artifact to be added to it, they have not enabled it to add like jar files to it yet. So
Okay.
even though the spec allows for it to happen, like the Maven or any of like the Maven release mechanisms don't know how to talk to the OCI registry for persistence.
Okay.
So, and that's one of the things that Alex, Andrew, and Kat and Jen have that intermediary client, and that client does the translation between like the Maven or Gradle language, protocol to the OCI registry. So they're the man in the middle that does the translation, and that's what Emporus is really getting into.
Can I ask one more question? Sorry,
Yeah.
everybody, if it's okay. I hope I'm asking questions that people are learning from. So going forward, could I implement, say, Emporus and Ortelius are happy chappies, they're connecting, there's an integration. Could I deploy Emporus and Ortelius together and use that as a way of dishing out, or with Persia, could I use that could I configure it in a way that I could use it for my developers at my company without having to use a Nexus machine, a Nexus
eventually,
service? Nexus is
yes.
Okay, but not at the moment.
That would no, because so like Nexus is mainly, well, it supports like Docker images and supports a bunch of package languages. Same with Artifactory. But what ends up happening is that middle layer, that man in the middle, doesn't exist yet. And that's where the Emporus man in the middle for the Java, Golang, those plugins have to be written so you can do that. And the long-term goal that Red Hat had for Emporus was, I need to go to this company and I need to stand up this server, and I need to bring all these dependencies.
Yeah.
And instead of going out and collecting all of the dependencies from Maven Central, going out collecting all the dependencies from Golang and PyPy, that they're all in one single registry that I can back up and just ship over to a customer, stand it up in a couple minutes, and they have all the dependencies ready to go.
Yeah, exactly.
Now the IPFS driver under the covers, what that would allow you to do is, if they implement with the IPFS driver, when you stand up that company's server, the IPFS would kick in and start downloading things and populating that server automatically.
Oh, that's nice. And obviously it'd be smart because it's got the peer-to-peer technology like torrenting and find the closest peer, right?
Exactly.
Saving you bandwidth and cost, of course, because cost in the cloud would be reduced in terms of bandwidth, hopefully. Hopefully the cloud providers would have something internally then.
Yep. And I believe, I haven't looked at the IPFS protocol for that storage driver for OCI, but from what I remember, the libp2p for that Persia was using, you could set it, you can configure it different ways. You can go to your peer and say, hey, peer A, do you have this file? And if peer A didn't have this file, then peer A would go ask peer B, do you have this file? And if peer B didn't have this file, it would go off and ask peer C. Peer C has it, and then it would download it to peer A. So it would do this like searching for dependencies. So what ends up happening is your peer A would not have the whole world in it. It would only have what it actually consumed at that level. So it has a subset of everything. So that's the whole peer-to-peer networking piece.
Interesting. It sounds like DNS for dependencies.
Yeah. Yeah, it's kind of like how the BitTorrent, it's exactly how the BitTorrent would work. You know, if I don't have it, I go ask somebody to go get it for me, type of thing.
Mm,
And then I have it, and then the next person next to me asks, do you have it? You have it, and that type of thing. That's the whole concept behind the peer-to-peer networking world.
yeah, makes sense.
So on that
Makes sense.
slide deck, we did ask Jim about funding, and he thought our number is a little bit low. The 150 for, I think, 2 developers, 1 developer for like 5 or 6 months. So we're going to go through and up that number and rework it. And we have to do the presentation with Omkar at the OpenSSF. I'll let them know what we're trying to do on that front. Other things that I found that what we need to do to start gathering the data is I've found that most of the registries that are out there, like Docker Hub, Artifact Hub, even like I think even Maven Central does it. You could do an RSS feed, and you can go and RSS feed those repositories and get notified when an update comes across. So what that allows us to do is we can start looking for and monitoring the repositories. And when a new release is made, we can go grab that release and grab as much information from that release as possible. The thing that's missing when we go this route is we don't have any of the CI/CD pipeline information. So there may be things that we need to do to go hunt that down to get the CI/CD information, like what was the git commit. And if we can get, that's the main thing we need to be able to associate is the artifact to the git commit. Once we have those two, we can clone the repo, find that git commit, do a bunch of interrogation about that repo and stuff like that at that level. But it's kind of like a sidecar version of monitoring repositories. It's we have to do some more research on that to see what we can grab, and you can even get into like if it's a GitHub action that built this, you can get to the logs and things like that and dump the logs to get more data out of that. But it's going to be a limited set without going into the pipeline, being inserted into the pipeline process.
So Steve,
Yep.
yeah, so that monitoring part is just for our internal microservice applications, or
It would be, let's say we want to, so the way I'm kind of envisioning it is take our Docker build that happens. So we have, when we do our Docker build of our one of our microservices, we know that we'll just take one of the Python ones for simplicity's sake. So we know that that Docker build, we have the image of it, and we know in that image it was dependent upon, for example, ChainGuard's Python base image. And then also we know that we're dependent upon some PyPy modules. So with that information, we can now go ahead and do an RSS feed to those packages. So we can subscribe to RSS feed on the ChainGuard Python image. We can subscribe to PyPy RSS feeds for all the packages that we're dependent upon. And if any of those change, we know we have to go ahead and rebuild and do create a new image, new Docker image on our front. And so, for example, if ChainGuard Python images change, we want to be able to go and grab the SBOM for that new ChainGuard image, and then do our rebuild of our images. And then same thing with all the Python modules. So that's kind of like where we kind of keep on going. And then if we get a new SBOM out that has new packages that we're dependent upon, we want to add those to the list to start monitoring. So what ends up happening is we keep on expanding what we're monitoring and expanding the data that we're collecting. Does that make sense?
Yeah, that makes sense. So I think if there is already something, some library or something that we can leverage, well and good. But I think I can build a solution that can do the same.
Yeah, it's we have to see if there's a Golang library for RSS feeds. We may not even need a Golang library for RSS feeds. So when you look at RSS feed, what it is the server. Let me see if I can find one real quick. Let me share my screen.
So basically Napster wasn't a bad idea.
No, no, it wasn't.
Showing my age now, Steve.
Yeah. Running it on your 286.
Yeah, exactly. My Pentium 1.
Yeah, your leftover old PC in the corner was your Napster.
Absolutely.
So let me.
So, one quick note: our CVs code are pretty bad right now. It downgraded to C from a couple of days, so we have to fix that.
You broke up a little bit. Did anybody catch that from Arvin?
Yeah, the security report is the C. Arvind is mentioning that.
Yeah. Yeah. So this is. So if I go back here, so we can see here. There's going to be the RSS feed button, and when you click on that, basically it's a URL to the XML file. And whenever there's an update, this XML file gets updated. And that's where you can basically, it's kind of clumsy because you have to go and pull and pull the XML files. So, and see if there's been new entries made in the XML file.
Correct.
But
yeah, so I think the basic idea for any monitoring services, you keep on pulling the data, and whenever there is a change, and whenever you detect some change in that data, you notify the client, right?
Yep. And I'm thinking when we find a change that we throw out a cloud event of some sort saying that we have a new change. And what we would have is we would have a long list of basically RSS feeds that we need to kind of pull and look at. And this, what we could do is you could actually, we could get into some fun Kubernetes parallelism. So we could take, and let's say we have 10,000 RSS feeds that we need to go ahead and query. We could take each, we could have the same like microservice or same job. It basically would be a Kubernetes job that you'd spin up like 100 of them. They each take 10 pieces of the URLs, go off and query and bring out and do the event listing on. So we could get some fun parallelization out of Kubernetes with the job, going through and scraping, bringing in and then kicking out the cloud events for the ones that have changed. But what we need to do is we need to kind of think about when we do this RSS feed and we do have to we do know that something has changed, what do we do? That's kind of the next step that we need to figure out is what do we do when we know there's a change? Do we know, like, for example, on the Docker side, if we have a new base image, what do we do? Do we do take the SBOM or go try to find an SBOM? Do we generate an SBOM? Do we send out notifications? Those type of things. So that's kind of where my head's at on those two topics with the AI stuff. Wanted to bring you up to speed on that. Sasha, as soon as we clean up that slide deck, I'll let you know for you to pass it around. There's a couple slides we're waiting on Andy and the Empower side to fix up. Should be done in the next week or so. And then we have the RSS feed, and then also from the architecture on the XRPL stuff. Utkarsh, I did look at your code. It looks good. I gotta get in and start playing with it and kind of plumbing it together. So that's looking good with that repo that you put together for the abstraction layer. And then basically the basis. Yeah, go ahead.
No, sorry, the layer between Emporus and Guac. Are you still looking for that flow? You were asking me
Yes.
about it.
Yeah, so we need to get Guac up and going and see what they're doing on that front.
You need a piece that's just between it, right?
What we need to do is we need to understand how we can leverage Guac. I know they have a bunch of what is it, GraphQL endpoints. We just need to be able to.
You wanted the messaging between the two. You wanted something that sits in the middle. It's like an integration, right?
Yeah, exactly.
A messaging integration.
Yep, exactly.
Jeez, I've got a perfect tool, but it's not open source.
Yeah, and then there's another. Well, we have to think about the cloud events, how we're going to pass them around and stuff. There was I don't know if we want to do a pub sub thing or, I'm up in the air on that front. I haven't really gotten that far down the road yet.
There's a guy in South Africa who wrote an incredible tool. It's a product. Unfortunately, it's not open source, but it can translate messaging between any database system, any messaging system, and it can format. It can spit it out the other side to whatever format you need it in. You can stick it in anything.
Cool.
And it work, and it can do billions of transactions a second. It's for like I just wish you could do a piece that's open sourced. Piece of it. Yeah.
Do we have any message broker in CNCF or CD Foundation? No, I guess.
There was one. There was a message broker I found that it's basically like RabbitMQ on steroids type of world. And it was
Spring Flow as well, something like that. I've seen.
I'd have to. I'll look up, see if I can find the project. But there is one, and it's sat on top of. It was weird because it could sit inside of Kubernetes, and then it could sit outside and connect multiple Kubernetes clusters together. So it was like this extra. It was way high up on the message brokering side. So, and it made it really nice to be able to, like you said, do the routing and stuff like that.
You can run any messaging from any system as long as if it makes a message, you can use it as an adapter in the middle. Really,
I believe so.
Yeah.
Yep.
Yeah, that's exactly what this thing does. Some exactly similar.
So I'll find that project and I'll let you know. I'll drop it.
Maybe we could use that, right?
That's what I'm thinking. We got a lot of moving pieces, and we just gotta kind of get focused and get things moving along.
Steve? What is your vision for us to focus on in the immediate? Once you've had holidays and you guys have you've come back for architecture, yeah. I'm just kind of interested because there's so many things going on, like with Emporus fitting in, and there's Persia also sort of hanging out there, and then there's Guac, and then there's there's salsa, and
so
sounds like we're making food.
now that we're gonna have Taco Tuesdays. So the next step for me that I'm focusing on is taking what Utkarsh did on the abstraction layer and getting the basic flow of creating a component, adding it to the database, adding to NFT storage, and then coming back and retrieving that path. So at a component version level, and then from there build up a UI to render that, just a single data for a single component.
Okay, cool. And then
once we have the plumbing kind of in place, then we can start doing other adding on like application versions, domains, users, groups, those type of things.
Okay, so that's the first core, and then what is that afterwards? The sort of the Emporus guys are working on the integration with Ortelius kind of thing.
Yeah,
they do.
they have to stand up a POC on their side, and like part of, once we get the base component version going, then we'll be able to see if we can hook guac in, if it's worthwhile or not, to pull in additional dependencies at that level.
And could I use, and the Terraform, my Terraform, could we use that as a local thing to say for people?
Yes, we will need the local Terraform for running in kind for all the development in the world.
Okay, cool.
And I think the Helm charts are still broken on that front.
No
I just haven't
worries.
had a chance to look at them.
Yeah, go to Portugal, rather come back and do it later.
Yeah. All right, whirlwind tour. We'll get this sorted out.
No, it's super exciting, eh? I mean, this is such an awesome space.
Yep.
We have a massive use case for it.
Yeah, we have like I said, once we figure out once we get to the point where we're starting to automatically collect data, then the fun starts. Once we have that persistence down and we're able to take that data and start working with it, then we'll have a lot of fun with what we can do with that data.
Okay, cool.
So I will share the link to the presentation, the AI one on Discord, and there's another spreadsheet I'm working on, like all the things that we need to collect as part of the pipeline. I'll share that spreadsheet as well on Discord. And then we'll just keep plugging along. Like I said, my next goal is to get the component getting created into persisted, and then working our way back and get some basic UI things so we can visualize it.
Cool. Thanks.
Makes sense?
Makes sense now, yeah.
Yep.
All right, I got to run off to another meeting.
Okay. Cheers, everyone.
Cheers, everybody.
Bye.
See you
everyone.
guys. Bye.
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 Bye bye.